Hello everyone, this is Manohar Reddy, Assistant Professor, Department of Cybersecurity, Institute of Aeronautical Engineering. Today we are going to discuss about the next concept in the database management system, expressive power of algebra and calculus. Expressive power of algebra and calculus. In the previous sessions, we already discussed about different types of relational algebra operations and different types of relational calculus queries. So there are different types of tuple relational queries, domain relational queries, and different types of relational algebraic queries will be there. Now in this session, we are going to discuss about expressive power of algebra and calculus. Let us see how it works and what are the queries we have to write. So first of all, what is meant by expressive power of algebra and calculus? So expressive power is nothing but we are going to write the queries in unsafe queries. We are going to write the unsafe queries. That means we are going to build a query which retrieves a finite number of solutions. So we have to write unsafe query to express the power of algebra. So what we need to do, we have to write the unsafe query to express the power of algebra. So for that, we are using different types of algebraic operations or operators also. And similarly for the relational calculus tuples and domain relational calculus. So see, syntactically, unsafe query is a syntactically correct calculus query that has an infinite number of answers. Means we are writing a unsafe query which retrieves finite number of answers. Example, this S represents a number of solutions from Sailor's table. So the Sailor's table shows a list of tuples, a list of answers, and it retrieves a finite number of answers. So every query that can be expressed in relational algebra can be expressed as a safe query. So every query, whatever the query we are writing in the relational algebra is expressed as a safe query. In domain relational calculus or tuple relational calculus. And the relational completeness query language can express every query that is expressible in relational algebra. So that is expressible in relational algebra. In addition that commercial query languages can express some queries that cannot be expressed in relational algebra. So that means some queries cannot be expressed as a relational algebraic operations or relational algebraic queries. But some queries expressed as a relational algebraic queries like TRC, DRC, tuple relational calculus or domain relational calculus. So the main importance of expressive, the power of algebra and calculus is what? Writing the unsafe queries in different modes. With the help of relational algebraic operations. So we'll see how we are going to write the queries, unsafe queries. We'll see. So we can write unsafe query into two ways. One is query on relational calculus. So relational calculus is nothing but what? We are writing the non-procedural query to retrieve the multiple values from tables. And the second one is what? Query on relational algebraic equation. So this is what we can write the queries by using different relational algebraic operators. With the help of these operators, we are going to write some relational queries. So query on relational calculus, we already seen with the previous sessions, tuple relational calculus and domain relational calculus. So and for the query on relational algebraic equations, we have to understand that symbols for all the relational operations. We have to understand all the different types of symbols for the relational algebraic operators. So we'll see. The next slide will show you how to define the symbols for all the operations of relational algebra. So look at the symbols, the operations of relational algebra. The first one is what? Select. So what is the operator name is select, and the purpose is what? Selects all tuples that satisfies the selection condition from a relation R. It selects all the tuples. All the tuples means all the records from the table, and that satisfies the selection condition from a relation R. And we can represent with the help of sigma symbol. We can represent the sigma symbol. So sigma symbol, and you have to mention a condition, selection condition, and then next relation, right? So this is the purpose of this select operator. And then next one, project operator. So projector operator, the purpose of this operator is to produce a new relation with only some of the attributes of R. A new relation, it maintains a new relation with some of the attributes of R and removes duplicate tuples. It removes the duplicate tuples as well as it displays some of the attributes. And you can specify with the help of the symbol pi along with the attribute lists, and relation. Relation is nothing but here we can mention that as a table. Next one, join. Theta join or natural join, equi-join. You can have different types of joins out there. So in that theta join, it produces all combinations of tuples from R1 and R2. So that is nothing but table 1 and table 2. That satisfies the join condition. And you can represent with the R1, and the join symbol is like this one, along with the join condition, along with the second table name. So first table, join type symbol and join condition, and second table. Next one, equi-join. So equi-join also produces all the combinations of tuples from R1, that is nothing but table 1 and table 2. That satisfies a join condition with only equality comparisons. It uses the equal operator and along with the condition, so that it is said to be equi-join. So it is the two tables are joined together based on the equal operator and the condition. So we can represent with the help of the symbol R1, join type and join condition R2. Or else you can specify like this also, R1, join type, join attributes 1, join attributes 2. Join attributes means what are the fields you want to join with the two tables. What are the fields you want to join with the names, you want to join with the IDs, you want to join with the age marks. You can take any of the columns from the two tables. So join together. The next one, natural join. It is also same as equi-join, but except that the join attributes of R2 are not included in the resulting relation. So R2 attributes are not included in the resulting operation. If the join attributes have the same names, they do not have to be specified at all. If the join type of two attributes are same, then you don't want to mention the fields. So here the join type notation is what? R1, natural join indicates like a star operator, then join condition, then next join table, second table. R1 star, that is nothing but R1 first table, the next join type, and then next join attributes 1, 2, along with the join table second one. Or else you can write simply table 1 star table 2, table 1 star table 2. So like the way you can specify natural join. The next union operator. So union, intersection or difference, these are all the set operators we can call it as. And here union operators produces a relation that includes all the tuples in R1 or R2 or both R1 and R2. You can take union means it is combining all, and but it does not included all the duplicates. It does not included all the duplicates, but instead of including all the duplicates, it is indicating only one value. It is indicating only one value. So R1 and R2 must be union compatible. The representation is what? R1 union R2. Next, intersection. Intersection operator. This operation produces a relation that includes all the tuples in both R1 and R2. It includes only both R1 and R2. Or R1 and R2 must be union compatible. Those two must be union compatible. So you can indicate as a R1 intersection R2. You can indicate it as a R1 intersection R2. Next one, difference. Difference is nothing but minus in set operators. So it produces a relation that includes all the tuples in R1 that are not in R2. That are not in R2. So R1 includes R2 not. So R1 includes R2 not. That is difference operator. And R1 and R2 must be union compatible. Those two must be union compatible. The next, Cartesian product. Cartesian product. It produces a relation that has the attributes of R1 and R2. So it must be having some relation both from R1 and R2. So both from table 1 and table 2. And includes as tuples all possible combinations of tuple from R1 and R2. So both having the combinations, both individual relationship as well as both will be the combinations. So each and every attribute from the table 1 and each and every attribute from the table 2 can have a relation to each other. So that is this representation is R1 into R2. And last one, division. It produces a relation R of X that includes all tuples of table 1 that appears in R1 in combination with every tuple from R2. So that is nothing but it includes all the tuples from table 1 that appear in R2, that appear in second table. So it is a combination of both R1 and R2 that represents like R1 of Z divided by R2 of Y. So like the way you can specify the division operation. So these are all the different types of operations of relational algebra. So to perform the relational operations, selection operation, projection operation, theta join operations, we have to specify these all the types of operators. So now we'll see how to write the queries in unsafe queries. So we know that a selection operator indicates with sigma, and the condition, it specifies the selection condition, and the next table name. So they asked me to write the query to select the employee tuples whose department number is 4. So we can have an employee table, like suppose this is an employee table. Employee table contains employee name or department number, employee ID, the next department number, next employee name. Suppose so employee ID is 101 or 1 or 2, and department number is 4 or 5, and department employee names are Ram and Raj. So now from this table we are having a 3 attributes like employee ID, department number, and employee name. Now what is the query? And in what way I need to write? I need to write the query in unsafe queries. That is the importance of expressive power of algebra. We have to write the unsafe queries, right? So because to getting a finite number of solutions, finite number of answers from a different tables. So now you can see query to select the employee tuples whose department is 4, whose department number is 4. So now this is the employee table, consider this, and here the department number is 4 and the employee ID is 101 and the employee name is Ram. So now how can I write the unsafe query? Generally I can write the procedural query like what? Select department number So how can I write select the employee tuples means I need to retrieve all the employee table tuples. So select star from employee table. The table name is what? Employee, and where department number equals to 4. So where the department number equal to 4, all the tuples will be displayed. All the tuples of the department number 4 employee will be displayed. So now the result is what? Employee ID 101, department number 4, and the name is what? Raj. So this is the output you will get. But I just want to write unsafe query, right? So unsafe query, how can I write? So I need to indicate the selection with the help of sigma operator. So sigma operator along with the condition. So condition is what? Selection condition. Department number equals to 4. Then next, on from what table? What table I need to get all this value? I need to get all this value from employee table. So this is the unsafe query. You can write in to representative expressive power of algebra. So sigma of department number equals to 4 of employee. This is the employee is nothing but relation name, that is a table, right? So this is the way you can write the relational algebraic query. This is the way you can write a relational algebraic query. Meanwhile, when we are writing the unsafe queries, we have to use some different types of operators, like comparison operators is normally one of these operators. So equal operator, may not be equal, not equal operator, greater than operator, greater than or equal operator, less than operator, less than or equal operator, and operator, or operator, and not operator. These are all, you can say that, comparison operators. Comparison operators which included to write unsafe queries. Which included to write unsafe queries. So department number equals to 4. Here I am writing a comparison operator because I want to mention that department number equals to 4. So that I use this comparison operator to represent the department number 4. Right? So this is the way we have to represent a relational algebraic query in the selection order, in the selection operation. Right? And the next one is projection operation. Next one is projection operation. We'll see. Before that, one more example we'll see. Query to select the employee tuples whose department is 4 and a salary greater than 25,000. This is one condition. And the second one is OR, department number is 5 and the salary is 30,000. Salary greater than 30,000. So I just want to display the employee tuples, all the employee tuples on two conditions. One is what? One is department number equals to 4 and salary greater than 25,000. And our second one is what? Department number is 5 and salary greater than 30,000. Salary greater than 30,000. So on these two conditions, I need to retrieve all the tuples from the employee table. So how can I write this query actually? So generally you can write the query select star from employee where department number is 4 and salary greater than 55,000, or I can use both and or operators. So I can write, how can I write? Generally select star from employee where department number 4 and salary greater than 25,000, or the next department number equals to 5 and salary greater than 30,000. This is the way I can write in normal procedural language. But what should I do? I just want to write in an unsafe query. So this all the query you can rewrite it as selection condition. So department number equals to 4 and salary greater than 25,000, or department number equals to 5 and salary greater than 30,000. from employee table. From employee table to selecting all the tuples. So this is the way you can understand the query, and you can write the unsafe query answer. Unsafe query. Right. So this is about selection operation on relational algebra. Selection operation on relational algebra. We are doing all these things for only to express the power of algebra and calculus. So next one, project operation. So in this, it is a list each employees. So we are writing the projection operation for projecting the particular values. That means what are the things I need to display from the table. So I need to display from the table last name, first name, salary of each employee from the employee table. So I just want to display employee last name, employee first name, salary from the employee table. So how can I write in this unsafe query? So I am writing unsafe query because of with the pi symbol. That is nothing but pi symbol. That is projection operation or project operator. You can say that. So now the query is what? List each employee's first and last name and salary. I just want to display each employee's first and last name and salary. So generally, how can I write? Select first name, comma, last name, comma, salary from employee. This is what we write in the normal query, normal procedural query. But for this unsafe query, we can indicate these attributes. These are all attribute list. These are all attribute list with the symbol pi symbol, and then next relation operator or operator. So pi and the attributes list, and then next relational type. That means table type, right? So this is the way you can mention what are the things, what are the attributes you want to display, right? So this is the way you can understand the project operation. And the next, so we'll see, we have to apply select and project operation on some queries. So what are the queries we can apply both select and project operation? We'll see. So here one is example, query to retrieve the first name, comma, last name and salary of all employees who work in department number 5. So I want to display all the employees first name, last name and salary whose department number equals to 5. Department number equals to 5. So how can we write? So we can write first of all the condition of selection statement, because we are having a selection condition who work in the department number 5. So we can write the query as like this. So I just want to display selection operation to display all the tuples, sigma whose department number equals to 5, then next is employee. So now it displays all the employees under department number 5. All the employees department number under 5. Now what I need to do? I need to display only the last name, first name, salary of all the employees working under department number 5. Right, working under department number 5. So I am projecting to display what? Last name, first name, salary of each employee who works under department number 5. So now you can write like this. So pi of. So what are the things I need to display? Last name, comma, first name, comma, salary. On what condition I am going to display means to selecting the department number 5. Selecting the department number 5 on which table? Employee table. Which table? Employee table. So this is the way we can understand the both selection and the projection operation to write the unsafe queries. So sometimes it is going to display using both the selection and the projection operations, right? This is the way you can write the unsafe queries using both selection and the projection operations. And next one, we can see union, intersection, set difference operations. So union operation, intersection operation, set difference operation. So all of these operations take two input relations which must be union compatible. That means union compatible means it must satisfy some conditions. That is, one is same number of fields, corresponding fields have the same type. So same number of types it should be there, and corresponding fields have the same type. Corresponding fields have the same type. That must be the same. That is nothing but data types will be same. So column size will be the same as well as department data types will be the same. So now we'll see. So we are having some tables here. So SID, SNAME, rating, age. From these all the different types of tuple values are there. When we are representing this all these tables, S1 table, S2 table, then we are performing union operation on these two tables. It represents S1 union S2 and display the result as like this. That means it combines both the tables. S1 and S2 on the basis of same number of columns and the same type of data types. Same number of columns as well as same type of data types. Then it displays the union table. Similarly, intersection. So consider the two tables S1 and S2. The common values from those two tables will be displayed. That common values are nothing but these two. The common values of those two tables must be shown. So those two are the tables of S1 intersection S2 values. And next one, S1 minus S2. That means set difference operator. So difference operator means S1 and this is S2. So S1 minus S2 means it displays only the S1, excluded all the different S2 values and excluded duplicates also. It displays only the values from S1. So for this union intersection set difference operator, you can mention directly as like S1 union S2, S1 intersection S2 and S1 minus S2. Like the way you can understand union intersection and set difference operators. And next one is renaming operator. So renaming operator is used to rename the column from the table name as well as table itself. Rename the column from the table name as well as rename the table itself. So here I am using the symbol for renaming. Row is an operator to renaming the column name as well as renaming the table name. So we can rename column name as well as we can rename table name as well as. So we have to rename those two only. Right. Now you can see how can we rename the columns. So this is the column 1 belongs to SID1 and column 5 belongs to SID2. I can represent with the help of both S1 into R1. So those two tables can have this SID's column. So the first one is replacing with SID1 and the fifth one is replacing with SID2 columns only. Right. So this is the way you can rename the operator, rename the columns as well as rename the tables. And the next one is conditional join. So generally join is used to combine the two or more tables and retrieve some values, right? So condition join, it specifies the join type along with the condition. So it represents what? Join symbol as well as condition name. So see here, R join condition with S. That means two tables, R table and S table joins together with the join condition. And you can write similarly as like this, sigma C of R into C. Now you can combine those two tables, S1 into S2 or R1 on basis of the condition S1 dot SID less than or equals to or anything you can write R1 dot SID. So that means S1 dot SID is there, table 1 column, and R1 dot SID is a table 2 column. So I am taking the condition as S1 dot SID less than R1 dot SID and joining those two tables. S1 joins with the R1. S1 join with the R1. So two tables are joined together on basis of S1 dot SID less than R1 dot SID condition. Right. So this is the way I can represent the conditional join operation. And here you can see some examples. So first of all, find the names of sailors who have reserved a boat 103. Who have reserved a boat 103. So here I can have three tables like generally sailors table. One is sailors table, and the second one is reserves table. Second one is reserves table, and the third one is boats table. Third one is boats table. So you can create these three tables and mention the boat IDs also, and write this query as a normal way. So we can write the unsafe query with the help of this projection operations. So look at here. So find the names of sailors. That means I just want to print names of sailors table. So name column from sailor table, and then next who have reserved boat not equals to 103. Boat equals to 103. So I just want to print the names of sailors who have reserved a boat 103. Who have reserved a boat 103. So how can we write the query? Generally we can write the query, select names from sailors where reserved boat ID equals to 103. Boat ID equals to 103. But for this relational algebraic query, for this unsafe query, we can write like this. I just want to print what? S name. So pi of S name, I am projecting to display names of selection condition on what? Selection condition is what? Boat ID is equals to 103 on two conditions joined together. Reserves into sailors. Reserves into sailors. So these two are the tables, and from these two tables I am going to retrieve the names on what condition? On BID, boat ID equals to 103 condition. 103 condition. So this is the way we can represent the join condition in the relational algebra. And similarly, solution 2. We can use without any temporary variables here, but here we can use another table called temp1. Temp1 is another alias tables you can create for to storing all these values, temp1 and temp2. So temp1 is having a reserves table, and along with the BID, boat ID equals to 103, and the temp2 is going to store the values joining after temp1 and the sailors table. Right. After that, is name of all the employees from temp2. It displays all the employees names from temp2 values. And you can write the another way like this also. So pi of S name, what you are going to display and what condition you are going to display, and what are the tables you are joining. Reserves into sailors. Reserves into sailor. So this is the way you can understand the query, relational algebraic query, and writing unsafe queries. Writing unsafe queries. We'll see another example also. So here one more example. Find the names of sailors who have reserved a red boat. Who have reserved a red boat. So here the information about boat color is only available in boats. That means boats is a table which contains boat color, boat IDs. So need an extra join with boats. So I need to join with a boats table also. I need to join with a boats table also, because boats colors will have in the boats table. Boats color will have in the boats table. So I need to display what? Names. So names of table, on what condition I am going to display? Boats table. Boats table condition is what? Color red. So color red from the boats table, and it joins with the both reserves table and sailors table. Reserves table as well as sailors table. Right. So you have to understand this what query. So first of all, we have to understand the query belongs to one table or two table or three table. But sometimes they given like the boat ID is belongs to, or boat color is belongs to boats table. So that means indirectly we have to take three tables. Indirectly we have to take three tables. So taking the three tables, boats table, reserves table, sailors table, and what condition I am going to display the names. What condition I am going to display the names. So the condition is what? Color equals to red. So this is the selection condition. This is the selection condition, and these three are the join conditions, like join joining all the tables, and this is what nothing but displaying the tuples. So I am going to display the tuples on this condition from these three tables joined together. Similarly, you can see another solution also. So I am going to print the sname from SID and boat ID and color of red from boats table. I am going to take the boat ID and boat color from the boats table. Then next I am joining reserves table with the boats table. After this, all result will be joining with the sailors table. So that this boat ID, boat color and boats table is joining with this reserve table as well as join with sailors table. So that a query optimizer can find the solution is as given first one appropriate. So this is the way we can understand the query to write the unsafe queries in the normal or non-procedural language. And we'll see another query also. So find the names of sailors who have reserved a red or green boat. So we have to use or operator or and operator as a logical or comparison operators, right? So what is the query here? Find the names of sailors who have reserved a red or a green boat. So first of all, what we need to do, identify all red or green boats. Then find sailors who have reserved one of these boats. So first of all, identify all the red or green boats identified. Then the finding sailors who have reserved one of these boats. So finding the sailors who have reserved one of these boats. So how can we write like this? We have to take one temporary boats as alias name to store the values who are reserved one of these boats. So then next what we need to write? So sigma of color equals to red or color equals to green. That means we are specifying the reserved a red or green boat, right? So the color equals to red or color equals to green from boats table. Then next what we need to display? We need to display a name. So I need to join together all these three tables. Boards. So what it contains? Temporary boards contains either red or green color boards, and the reserves table contains this all the information, and the sailors contain who have reserved a boat red or green details, right? So sailors have the details of red or green boat reservation table. So now you can write this query and you can execute the query. So temporary boards can also be defined using union. What if we are replaced by and in this query? So if I am writing and operator in this query, what it displays actually color equals to red and color equals to green. That means both boats will be displayed. Both boats will be displayed for the employees or sailors in the sailors table. So who have selected both red and both green color boats can have the sailors will be displays. So this is the way we can write the unsafe queries in the relational algebra, right? So this is what we understand from this expressive power of algebra and calculus. So we'll see how what we discussed from this session. We'll see first of all we have to understand what is meant by expressive power of algebra and calculus. So we are writing the unsafe queries to get the finite number of solutions. So we can represent with the help of different types of relational algebra queries as well as relational calculus queries. We already seen that relational calculus queries, how can we write and how can we execute them. And similarly, we have to write relational algebraic queries. So here we can see all the different types of symbols for each and every relational algebraic operator. Right? So after writing all these operator symbol and the purpose, we have to understand that every query Every query can have different operators like selection, projection, renaming, set operators or join operators, right? So based on that operator and based on that query scenario, we have to build a unsafe query. And meanwhile, by writing this all the queries, we can include these comparison operators also. We have to include these comparison operators also. So selection operation, projection operation to representing or projecting all the values, projection operation, and then next union, intersection, difference operators, and the next renaming operation, and the next conditional join operation, and next we have seen some examples. Right? So uh, this is all from expressive power of algebra and calculus. So to represent this all the join operations and all these, we have to specify that the column size of the table 1 is equivalent to column size of the table 2, and data types from the column table 1 is equals to table 2 data types columns. Right? So this is all about expressive power of algebra and calculus. Right? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.